Hi, I'm taking Paul McWhorter's AI for Everyone lessons, and after a well-deserved break, we're back on lesson 24 with gesture detection and recognition. Um, so Paul basically wanted to know where we were at with this, and what our best guesses were to how this works. So I I know that my way is brute force and not very AI. So but I'll show you where I'm at. So my approach to it was to just compare the number 20 and number 18, number 16 and 14. Whichever one of these was closer to the zero, it would determine whether it was a finger out or a finger curled. So did that for each of the four fingers on the hand. The thumb, it's a special case because you really don't curl that compared to anything on its regular on its joints. So what I did was I take the 0 to 5 distance and compared it to the 4 to 5 distance. If 4 to 5 is at least half of what 0 to 5 is, then we consider it out. Otherwise, we consider it in. The good thing about doing it this way is we're not using any static numbers or anything. So it doesn't matter how close or far away from the screen or the camera the hand is. The numbers are just differences in points on the hand. So it has good points and bad points. Also, but doing that will get you which fingers are in and out, but that doesn't, thumbs up and thumbs down and hitchhiking doesn't work with that. So what I do is I put a second conditional in at the end of that. If the four fingers are folded in and the thumb is out, which is the positions for the three we were talking about, then I go and I try to find out which way the 3 to 4 vector is pointing and determine our direction from that. So that's what I've been working on brute force wise. So let's go to the code. So Paul showed us a while ago how to do this Pythagorean theorem equation to get the distance between the any 2 points. So rather than having to rewrite this a bunch of times, I decided to turn it into a function, some short function up here. And we call it joint distance or JD. And we're just importing the hand and then the 2 points that we want. And it returns the distance between those 2 points. So a lot easier just to write that part than it is to write out that all the time. So we'll go down to our code, while true part of it. So I decided to use my Arduino knowledge to and just take a single byte binary number and just flip the different bits on it depending on which joint which joints are extended and which are curled. So we start out with a 0, 0, 0 if that's whether there's any hand or not. And then if it does find a hand, then first thing we do is we use this plus equals 1 bit shifted 7. So what that does is take this position value and add a 1 to it with the shifted over 7 bits. So we start at 0, so 7 is here. So if we find a hand, it becomes 1 and 7 zeros. And so we have that. And then we go down and we just do our distances on our 18 and 20. And if the finger's extended, then we make it a 1. So this is 1 bit shifted 0. So that would control whether this is a 1 or not. And then same way, ring finger and all those, just each one we're walking over. And then, like I said, when we get down to the thumb, we're taking the distance between 0 and 5 and divide it in half, and then comparing that to the 4 and 5 distance. And if 4 and 5 is bigger than half of 0 and 5, then we consider it extended. So we put a 1 there. Then we do a test down here. This is the number you would get if you have 4 fingers curled plus the thumb out. So if we have that, then we go and do the extra steps of finding whether we have a left, right, up or down thumb pointing. We just do the math on that to figure out which way it's pointing. That's actually changes the 5th and 6th bit difference there. That we're not using. We're using 0 to 4. So 5 and 6 are free, and 7 we're already using. So that uses up 8 bits. So we could use more bits if we had other things we wanted to check, but this is what I've got so far for this. I didn't bother doing any comparison to making text values. I'm just showing on this where the bits are flipped and just displaying the binary number with it. So let me get rid of my camera here on this so that I can actually run the program without crashing. Let's try this out. All right. So you see over here, we got 0 because there's no nothing attached. You can see the glitches in there, thinking that my face is a hand. So we'll put a hand up. And now you can see that the least 5 bits are the number are all 1s because my hand's out. So we can start with the little finger. We go down, take the 2nd one, 3rd one, 4th one, and then the thumb in. So then we got all that. So, that can be the power to the people. All you'd have to do is compare, the binary number to and make it equal to a text string or whatever. So, it works with thumb in, thumb out, and do a peace sign. It works pretty well. But like I said, I didn't change it into numbers, but it'd be a simple matter of matching numbers to text words if you wanted to do that. Now I'll show the thumb. So I got my thumb now. So we got our 1 0 0 1 0 0 0 0, and just the way it's coded, that it doesn't change when it's pointing my face. Both of them are 0s, but if I go up with it, then both of them are 1s. If I go down with it, you get a 1 0 there. And I don't know if I can turn this the other way. That's right. It doesn't usually get it too well. No, it's not getting it really. So there we go. So you get a 1 0 that way. So you get individual numbers over here that you could very easily attach to that. But one of the things that you don't get is you're not able to do like an AOK, or I think Paul showed in his live stream that he was doing the Star Trek Vulcan thing, and we couldn't pick that up the way it is. So I'm certainly looking forward to what Paul can show us on how to make this more artificial intelligent. So I know my way's not very good at all. So looking forward to what Paul comes up with. One thing I did want to mention is, if you notice, that was actually a GUI frame window there, not a OpenCV window that we worked on. I know in my previous videos I've been fussing about tkinter and how there had to be a better way, and I got it to work, but it was hard. So over the holidays, I looked into several of the different GUI things out there, and the one I settled on, which seems to be really easy, and I recommend it to anybody that's wanting to get started on graphical user interface for their program, is PySimpleGUI. It's you got to pip install it, but it's just a library that's available. You don't have to download it or anything. You just do the pip install and it comes in. And I really like it. They call each of like your buttons or any of they call them elements. Tkinter and some of the other ones call them widgets, but buttons and text boxes and everything are elements here. And on Tkinter, you had 3 or more lines of code for each element. And with PySimpleGUI, 1 line of code. This is the image image space that we're making for the coming into the for our OpenCV window that we have. So always got these things that we are just telling it to be, and comes up just fine. And then the text where I put the binary number out there, that's just another text box. And then like I say, 1 line of code for that. And then to place them on the layout, they call it, so it's just like a list of lists. So everything in the first column is the first list here on the first row is going to be listed from next to each other. And then you got a second list down here, and the only thing was down there was that quit button. And most of the time I like putting my elements separate up here because they can string out. But if they're nice and short like this SG quit, there's no parameters or anything that you need to put in there if you're just happy with the one. So you can just put, and that just puts a quit button on your screen, and that's basically all you have to do with that. And then interfacing it with Tkinter, you had to change up. You didn't do a while true. You had to have an event loop, they called it. This still has an event loop, and it has just this 1 line of code that creates a place where they can read your events. And you got to do that every, I got to doing it every 10 milliseconds. So you got to, got to be able to do it every once in a while as you loop through. So we're doing that. And then when you want to go ahead and display your frame or your ROI frame or anything else, it's just 1 line of code that puts it in. We called that ICAM up here. And it just knows that it's going to update ICAM with our frame data. And there's just some ways to get it in the right form, bytes, that the screen knows what it is, converting it from our OpenCV to our regular, something that the GUI program can handle. I am so happy with that. When I redid my my main program that probably has like 50 elements in it. It went with Tkinter, it was over 180 lines of code, and they were all mishmashed with no order to them or whatever. You just had to keep putting stuff in, and it was 180 lines of code. And in this PySimpleGUI, it ended up being about 75 lines of code, so well under half of what the lines of code. Plus, it's so much more readable. Just interacting with the GUI when a button gets pressed and everything is more straightforward in this and everything. I highly recommend it if anybody wants to start out with a GUI, trying to make themselves a GUI, to try out PySimpleGUI. It's pretty, it's well documented, and there's a lot of documentation, but if you started out with tkinter, you would be surprised that, oh, this is so much more easy, but there's still a lot, there's a learning curve to it, and you'll have to put in your time to get all the pieces, but the documentation is there, so you can go at it for sure. Anyhow, hoping to see what Paul comes up with for the gestures, and looking forward to learning from him. I'll talk to everybody later. Thanks.